Okay, so you're going to notice that we are now in section 8.5. That is not a typo. Okay, this is where we're going. Okay, between now and the rest of the year, I'm going to pick some things that I think are really important for you to learn. Okay, especially before you get into pre-calculus. And this is one of those things. And today we're going to talk about variation functions. And so first of all, we're going to talk about direct variation. Now with direct variation, this is how you will see a problem written. It will say y varies directly as x if there is some non-zero constant k such that y equals kx. We call k the constant of variation. So a direct variation example would be like y equals 3x. So where have you seen something like y equals 3x before? When we've studied what? Where do we look at problems where we'd see like y equals 4x, y equals 3x? Graphing, right? And so basically, this is in what form? What form would we call this? Slope, intercept form, right? And so our slope in this case would be what? 3. Y-intercept would be 0. So basically a direct variation problem is nothing more than something that's written in slope-intercept form where your y-intercept is always 0. Okay, and so direct variation, there are two ways we can solve these problems. One, we can use the constant of variation, or two, we can use proportions. And most of the time you use proportions because they are a little bit easier to understand. Now notice what it says. It says if y varies directly as x and y equals 15 when x equals -5, find y when x equals 7. And so if you remember what I said, we can use proportions here, and in fact that's what I'm going to show you as opposed to showing you how to solve it with the constant of variation, which is known as k. And this is what we're going to do. Basically the 1, that subscript, means the first value of y and the first value of x. Subscript here means the second value of y, second value of x. So I'm going to go ahead and start. What is my first value of y? 15, and it's paired with what number? -5. So there is what my proportion looks like on the left side. Now on the right side, what's it going to look like? Y over 7. Right. And I don't need to put the little sub 2. I could just put y. There's no need to have to write that subscript. And so now in order to solve this, I'm going to cross multiply. So I've got 15 times 7, which is 105, equals -5y. What do you do now? Divide by -5. So what does y equal? -21. Now some of you at one time when you learned proportions might have learned a shortcut way for doing the proportions all in one step. Okay? And here's how you do it all in one step. Multiply, divide. So you would multiply those two and then divide by -5. If you remember that, great. Okay? If you don't, you can go through and solve. It doesn't take that much longer. Questions on that? All right, this is your turn. And so what you're going to do, notice we've got r and t. You can do that. It doesn't always have to be x and y. It can be other variables. You can do that and go ahead and enter your answer in on your expressions. So once you get an answer, go ahead and enter it in. When we get all of them, we'll see how we did. and the answer is 30. Nice job. Okay. So what you should have had, what should you have had on the one side of your proportion? Negative 20 over 4, very good, equals r over negative 6. Very good. Okay, let's go ahead and look at joint variation. Now, joint variation isn't as easy as direct variation, but it's not hard either. Okay, joint variation basically means there's going to be more than 2. So it says y varies jointly as x and z if there is some non-zero constant k such that y equals k x z. Now notice here, key word, it says y, so that starts on the top. So whenever it says y, okay, that's where we start on the top. It says varies jointly as x and z. So notice where x and z occur. They occur in the denominator. So y is on the top, x and z are on the bottom. This is the formula you're going to use. So y over x times z equals y over x times z. All right, so let's go and look at an example. Suppose y varies jointly as x and z. So right away when you see that, you know it's going to be in this form. Find y when x equals 9 and z equals 2 if y equals 20 when z equals 3 and x equals 5. So you tell me what I need to write. Okay. Good, because that's kind of written a little bit backwards. Okay, because notice it says find y right away to the start when x equals 9 and z equals 2. So you guys caught that. That was great. Because the 9 and the 2 go with the y. The 20 goes with the 3 and the 5. So let's go ahead and solve that. When we solve that, we should get y over 18 equals 20 over 15. So if you want to do the shortcut to solve this, we multiply the 20 and 18 and we divide by 15. So what do you get y to equal? 24. Very good. Questions? It's your turn. All right, there you go. Answer on the expressions when you're done. Suppose y varies jointly as x and z. Find y when x equals 2, z equals 8. If y equals 70 when z equals 10 and x equals 4. So when you get an answer, go ahead and enter it in on your expressions. And we'll see how we do. Did you enter yours in? Okay, so let's see what we got. 28 majority. Nice job. So on the left side, we should have had y over, oh, gotta get my pen, sorry. Y over 2 times 8 equals 70 over 10 times 4. So really that amounts to y over 16 equals 70 over 40. So what we need to do, multiply, divide. Okay, so now we're going to talk about inverse variation. So now we've got direct variation, joint variation, and inverse variation. Inverse variation is a little different. Okay. Notice it says y varies inversely. So there are all these keywords that you need to be watching for. If it says varies directly, it's like the first one. If it says varies jointly, it's like the second one. Now it's going to say varies inversely. Now, inverse variation is a little different. Okay, I'll let you get the formula down, and then we're going to talk about that. Now, when we think about inverse variation, what that means is as something goes up, something increases, something else is going to go down to balance it out. So let's think about something with inverse variation. What happens if you go faster on the interstate? What happens to the time it takes you to get to Lincoln to go shopping? It goes down, right? So that's an example of inverse variation. So as you increase your speed, you're obviously going to get to where you need to go a little faster. Okay, something else, the inverse variation. You increase your spending, what happens to your savings account? It's going to go down, right? So that's something that's inverse variation. So you increase your spending, your amount of money is going to go down, okay, that you have available. So those are examples of inverse variation. Sometimes it's a little bit hard to imagine what inverse variation is, and so that's why we talked about it. Here's the formula you need to get down. Okay, now notice that, yes, those numbers are correct. x1 over y2, x2 over y1. Here's probably the easier way to remember it. Instead of looking up and down, oops, let's go back, for some reason we're back. Instead of looking up or down, the easiest way to do these inverse variations is to look left to right. So notice that the x's are on top in order. Okay? In the denominator, the y's are the opposite, so I start with the second y. So that's the easier way to view it. Let's go ahead and look at an example. If y varies inversely as x. So when you see that, I said y. I said that backwards, didn't I? Okay. If x varies inversely as y. So basically, this is what I see. Okay. The x's are going to go across. If it varies inversely, that means I'm going to flip the y's, and I've got y2 over y1. So write it horizontally with that inverse. I think it'll make a little bit more sense for you. Okay? When x equals 28, when y equals -2. So where are you going to put the 28? x1. Where are you going to put the -2? y1. So notice how that goes. Find x when y equals -10. So here's where x is, and then your -10 is going to be on the bottom here. So if I go ahead and multiply along the diagonal, I get -56. Divided by -10, I should get x to equal 5.6. Okay. Questions? Because it's going to be your turn right now. There you go. If x varies inversely as y, and x equals 24 when y equals 4, find x when y equals 12. Your turn now. Go ahead and enter it in on your expressions when you're done. Let's see how you did. The answer is 8. Nice job. Okay. So once again, you should have had your x1 on the top, x2 on the top, and then since it's inverse, we're going to reverse those on the bottom. So you should have had 24 on the top here, 4 on the bottom here. You want to find x when y equals 12. So what ends up happening is you multiply 24 times 4, divide by 12, and that'll give you your value for x. Think you can handle that? Your assignment then for tomorrow. Page 566, 7 through 24, 28, and 29. Now what they have done is they've put some story problems in here. Okay? They put some story problems in there. I want you to try them and see how they go. If you have questions, we'll start with questions tomorrow with the start of class.